Okay, the slides, this is the important thing here. Tiny URL, frictionless-data-science, and of course I'll get it onto the PG Open Wiki, so you don't have to worry about frantically taking notes. I've had a foot in the Python world and a foot in the database world for a very long time. But the most awesome thing about me is that I just recently started for 18F, which is a new government agency bringing open source agile coolness into the federal government. Look us up. Yes, I'm really excited. Thank you, yes. Your tax dollars are getting to work at last. All right. So Python and Postgres are best friends, BFFs, always have been. But sometimes they're the sort of best friends who are both so busy that they lose touch with each other, and they just haven't made time to have a phone call and catch up because they're both doing so many awesome things. That's kind of the situation we're in. And so I'm trying to make the sort of, when you finally get a phone call with them and you catch up on all that stuff, that's what I'm aiming for here. Find out what they've been up to. Do you know that there's an entire series of conferences now called PyData, just about data handling in Python? And yet most of the things they talk about there, I haven't heard about much of in the Postgres world. So I thought it's time for a catch-up call. Basically, I'm going to be looking at a bunch of different tools you can use to get data, manipulate it, serve it up in RESTful web services form, and visualize it. But first, I'm going to give a plug to the IPython notebook because that makes an awesome working framework for all these activities and virtually everything else you do. So, IPython notebook. What is this? Well, it's a big deal in the Python world. It won the 2012 Free Software Award. It's really taken over the PyData world. It is basically it's a web application, but each of these cells is a markdown cell, which means if we look inside, it's easy to edit like this. And then that is rendered that way. So some of the cells are marked down. Other cells are Python cells that actually execute. Oh, I didn't clear my, this is less interesting if let's clear all the output. All right. So these actually execute against a Python backend which is running on your machine. And it's an enhanced Python environment because it contains things that ordinary Python doesn't have, like say tab completion. Let's see, what starts with, oh yeah, conf, that's what I want. It contains, oh yeah, what methods are defined on conf? Well, quite a few of them. How about count? It contains help. If I start a function and then hesitate, it gives me a little pop-up with some information about how I want to use it. So it's a handy environment for experimenting your way along. It also has great operating system integration, so I can run operating system commands like so. The common ones don't need an exclamation point. If I'm using a somewhat less common one, I might need to get a laser pointer that works. Okay. If I'm using a less common one, I use an exclamation point at the beginning to say go out there and run it into, oh, I have to run it in the operating system. Incidentally, this is what a notebook file looks like on disk. It's a JSON file. So it's a JSON file, it's a web application, and it's a server Python process. It's kind of a complicated beast when you think about it that way, but it's easy to use. You can assign from the operating system into a Python variable. So I just captured the results of an ls in this Python variable files. And you're not stuck with just Python. Let's say you want to do Perl. I thought I cleared that cell. All right, whatever. Anything that can be scripted from the operating system command line can be done in IPython notebook. So this is great. You can run quick experiments and then persist them and come back to them later. Or you can add beautiful annotations to your experiments. I would love to see a lot of the queries that are on the Postgres wiki be converted into a form where the query is there and you can run the query, but the explanation for what the query means is also right in there, so you have kind of an executable document. Please do that, somebody. You can publish the results on the web really easily. In fact, you don't even need to host it. The project has an NB viewer for Notebook Viewer where you can slap it up online, and if you go to the tiny URL Frictionless Data Science, that's what's hosting it. And you can do presentations with it. This is dog food. This presentation is a live IPython notebook in presentation form. So as you'll see, I can mess with things as we go along. Of course, this wouldn't be much fun if we couldn't get at the database. So there's a SQL magic. These %whatever commands in IPython are all called magic commands. To use the SQL magic, you need to install a separate module called IPython SQL. And of course, you'll want the Python library for accessing Postgres. But once you've done that, you can hook up this extension and then connect to a Postgres database. That's what I just did. And then you can, as long as you prepend them with the %SQL, you can run SQL queries. And this renders as this HTML table, but in reality, it's being stored as basically it's a result set, but you can use it like a Python list. If it's a multi-line query, then you need to use 2 percentile signs. That's just what they call a cell magic instead of a line magic in Postgres, but it works the same way. And you can assign the results of that query to a Python variable, just like we did with the ls earlier. So now we've got those results stored in our variable, in the variable names. And we can look at one item in that array. And we can look at one value within that. So really handy way to make hybrid applications that just pop back and forth easily between IPython and Postgres and SQL. However, if you query a million rows, it'll try to display those million rows in the browser. So don't. And it also keeps an open session. So for instance, if you start messing with something in the notebook and then in a separate window you say, oh, I want to drop that table and recreate it, it'll hang because this has got it open. So you do want to be aware of things like that. I have a link here when you're looking at the slides yourself. You can see my last year's lightning talk on the topic, which covers a little bit more. But I want to move on to some of the new tools that are out there for getting data out of non-SQL sources and manipulating it, maybe more importantly. And the big one, yes?
Right,
no, please.
Curiosity. So if I change a parsed line, what happens to it?
If you change a parsed line?
Yeah, like so if you assign something and go back and like
it doesn't automatically persist into the database. It is one way. That would make it a full-fledged object relational mapper.
Like, it's fantastic already, though.
Well, thank you. Yeah, but yeah, I'm not going to rewrite SQL Alchemy. That would kill me. Yeah. And actually, it's basically a wrapper around SQL Alchemy already. So I suppose it wouldn't be that. No, don't tempt me. OK. All right. Yeah. So pandas is something that you will see absolutely constantly in the PyData world these days. Basically, pandas starts as Python's answer to R, if you've heard of the R statistical language. Most of that functionality is being duplicated in pandas, only in a much friendlier Pythonic way, and you don't have to learn a brand new language. There's a lot of other basic data handling capabilities that it adds. It's a high-level library. It wraps up a lot of the functions in NumPy, if you've heard of that. The basic object it deals with is called a data frame. It's a two-dimensional, it's a table, whatever. There's a lot of dependencies. So if you're not great at installing Python packages, you might want to just go with a commercial distribution. Anaconda and Canopy are both, basically they're packaged up for scientists who don't have time to be programmers and they don't have time to learn Python packaging. They're both really nice tools. You should consider using one of those if the installation is intimidating at all for you. Most of my information about pandas comes out of this book, as well as most of the sample data, so got to plug that. Very nice book. First thing you need to do is get data, which tragically is not always in a relational database to begin with. So this is all in IPython, of course. I'm importing the library and referring to it as PD. Basically, I've got some data out there in, well, it's a CSV, although it's labeled .txt. So how am I going to get it? Pandas has nice function. Ooh, I didn't need to do that. I'll just run that. Pandas has a nice read CSV function where you just pass it the name of the file, and in this case, the names of the columns because they weren't built into the file itself. And that assigned it to this YOB2000 variable. Now, what is YOB2000? Well, I could show you the whole thing. No, I'm not going to show you the whole thing. This is a pandas data frame. OK, this looks exactly like the SQL results from earlier, but it's a little different. It's a pandas data frame. It has, did I write that in? Let me show you. it has methods defined on it, like describe. So this gives you kind of a rundown of some of the instant statistics. Just a handy way for dealing with data. It has a bunch of other read methods in case it's not in a CSV. We can get it out of a Excel database or JSON or HTML or some other funky scientific data store formats that I don't recognize. So getting the data in, no problem. Next, we want to manipulate it. When you go and read the pandas documentation, you see them talking breathlessly about how awesome it is that they can filter, they can join, they can sort, they can broadcast, meaning they can apply a function to a whole lot of rows without looping. You can write up a Python function and apply it. They can group, and they can apply functions to the groups. They can even do moving averages. Isn't this awesome? Isn't it great that all this stuff that you can't do in a relational database? What? Of course we can do it in a relational database. OK, lesser relational databases may have troubles with it. So 90% of what Pandas does, we can do in Postgres just fine anyway. So if you just look at the Pandas documentation, you may say, there's nothing for me here. But don't stick with that 90%. It's worth taking a look at the other 10% that would be difficult in Postgres. I'm not going to say impossible. That's a dangerous word to say with Postgres. So what is something that is a little trickier in Postgres? Well, here's that YOB, year of birth 2000. By the way, these are stats on how many babies got this name in each year of each sex. So in the year 2000, yes?
When you assign YOB 2000,
yes.
read it entirely into memory?
It did, and Pandas is memory bound, and I don't know a great way around that. So get a nice big computer, I don't know. One of the easiest things we can do with it, if we want to transpose capital T, gives you the transposed version of it really quick and easy. Now suppose we want to sum not down a column, which would be easy in any mode, but if we want to sum across these columns. Pandas can handle operations that cut across columns really easy. In this case, I'm calling sum, but I'm passing axis equals 1, which means go horizontally instead of vertically. That's a funny name, but the point is we summed those numerical values really easily. So in general, one thing that Pandas is good at, better than Postgres, is when you're operating across a bunch of columns, especially across a varying number of columns. For my next sample, I've got data on about 10 years worth here. So I just want to run this little thing to build up a single data frame with all that data. Details of this one aren't important. What's important is, OK, now we've got a frame that includes what year it is so that we can start looking at data in year terms. So it begins with common female names in 2000 and ends with uncommon male names in 2010. And if you name your son Zizix, don't tell him it's because of my talk. Okay. People do this, OK. But let's take something a little less weird. Let's check out the name Leslie and all its variations. Here is an example of how you filter in Pandas. It looks a lot like, it looks a lot like picking out items from a Python list would look like. We're just picking out things that start with LESL. OK, well, there's a bunch of those. That's kind of interesting. Let's move on. But it's a lot more interesting if we make a pivot table. Pivot table is another thing that Pandas really excels at. All we have to do is tell it that we want to see the number of births, we want to see rows, year for rows, sex for columns, and then sum up those values, and we can get a look at how the name Leslie has been doing. And it hasn't been doing very well, has it? Wow, it's really dropping off. Oh well. Maybe we want to do a little exploration of gender here. Suppose now we are going over all years, but we are looking at names and what the breakdown is between girls who got the name, boys who got the name. And Pandas, unlike SQL, very, very forgiving about nulls. So you don't have to catch nulls at every opportunity. It kind of does the sensible thing when there's missing data. If you're summing a bunch of data and some of it's missing, no problem. It just goes on and sums. All right. Adding columns to this Pandas data frame, not a problem. We're going to add one column to show how many babies total were born with that name, and one column for what was the ratio of girls. Of all people with that name, what's the fraction of them that were girls? So we've, that's not interesting because those have nulls, but, oh, that's interesting. I told you that it was very forgiving, but look, those have not a numbers. Okay, you learn new things every day. In any case, and then I was trying to sort out the most androgynous names, and so I cooked up this function to kind of have something that I could sort on and bring the most androgynous names to the beginning. Apparently, the most androgynous, reasonably common name in America these days is Jesse. So, all right. One just little annoyance that happens in SQL a lot is duplicate data, and it's kind of a pain to get rid of in regular old SQL, as far as I know. I'm always going to find out that it's not. But so I've got Ohio in here 3 times, unfortunately. Well, Pandas comes with a really simple drop duplicates method. Now they're gone. But maybe I wanted to keep the last one and not the first one, which you might want to do if this is time data and we want to keep the most recent. In that case, you can just pass a take last argument in there. So one other example. But all of this is useless if you can't get the data into SQL. So I want to make sure we cover how you handle that. First of all, how do you get it out of SQL? Well, in this case, my database that I'm working with is empty except for one table. I did put year of birth 2010 records into my Postgres database to start with. There they are. So if I want to pull them into Pandas, I actually have to go and create a SQL Alchemy engine object and pass it SQL Alchemy's idea of what a connection string is. It's actually username colon passwords @ host / database name. But in some cases like this, it's really easy, and you can omit almost all of that. Then Pandas has got this read SQL table function, which will just pull it on in and assign it to the all people data frame. From that point, I'm going to apply another one of these Pandas filtrations and just filter out names that start with the letter X and pop those into a new Pandas data frame called X-Men. And hang on, I think I missed a slide. I want to see the X-Men. Let's see them. Oh, for heaven's sake. Oh, yes, I can't persist it. I already created it. Hang on. All right, X names. Okay, so that's right. Sorry. I deleted it. All right. I deleted my function, which in my method on the X-Men, let's see. I don't even remember the name of the method. Did anyone see it? It was the save as SQL method. I want to say it was it 2XML or save XML? 2CSV. There we go, 2SQL. So that's how I injected it back into the database. And that was not a very good live query. But anyway, I re-injected it into the database. So what I did, I processed data. I took it out into Pandas to process it, and then injected a new table into the Postgres database, which is a good thing. Now, in this case, the processing was only a filtration, so that would be silly. But if you had a more impressive statistical sort of processing, that would make more sense. Now, if you are using the IPython notebook, and if you're using this SQL shortcut, if you're using the SQL magic, then you have some nice shortcuts, because I can actually go grab that, grab the results of that YOB 2010, insert it into a data frame named, oh, not into a data frame. Grab it just into a variable named Chris, and there's my first top 5 rows. So that's how I got it out of the database and not yet into Pandas. But that result set comes with a data frame method, which when I run it, generates a data frame from it. And I'm assigning that into the variable Chris's. So I want to just kind of prove that that's, OK, so now Chris's is a data frame. Alternately, I can set IPython to automatically convert SQL results into pandas, so it doesn't even stop in regular Python objects on the way. And if you are doing big queries, this is a good idea. It will still be stored in memory, but pandas at least knows not to try to display all million rows on the screen. When you look at a pandas object, if it's more than like 10 rows, it gives you the first 10, ... last 10. So it's a little safer to run the big stuff here. Still does go into memory. All right. Now once AutoPandas is set, then I don't even need to take that extra step. Oops. That is not where I am. I didn't even need to take that extra step. Now, Eric's is a pandas data frame, and the SQL magic defines a special pseudo SQL bogus command called persist, which I totally made up, and its job is just to, because it remembers the database connection that it used to pull out of the database, its job is just to create a new table by that name. Let me try Chris's. I don't know where Eric's went. What did I do? I want to, oh, I see. My goodness, you're right. I'm trying to check that I'm done. Did I ever run my persist? Okay. Eric's. Okay.
So you can toss in the data frame directly through the SQL and call persist on it?
Once you've got it as a, let's see, SQL can give you a data frame directly if you set AutoPandas on, and then you call persist on the data frame. And yeah, in this pseudo, this pseudo SQL command, and that sends it on back into the database under the name, whatever name you've given the variable. So it's a kind of cheesy hack, but it is a shortcut. Oh, there's where, oh goodness. See, I'm executing my cells in the wrong order. All right. There's me proving that the data did end up in the database. Oh, okay. You saw this yesterday. Quick and dirty way to get data from external sources into SQL. So I'm going to go really fast, but just once I want you to see it with your own eyes, since the visuals went wrong yesterday. There's my CSV file. Here I am generating DDL corresponding. It runs over and inspects the data. Here I am generating it with insert statements and pumping it straight through into the database with a pipe. And here I am seeing the results in SQL. So I can do it. I could do it to, say, a table that happens to be in frankly, a kind of messy web page, but it'll work anyway. Okay. Ta-da! Yeah. No? Thank you. Thank you. It wasn't that hard.
No, but what if there were more tables?
I think it takes the one with the most data or something.
It looks for something that has headings defined. It basically gives everything a rating as to how much it looks like a real table. It looks at the number of rows, whether it has headings defined. That might be it for a while. And so because there's always your stupid formatting tables and things like that. But so give me examples of cases when it fails, because I'd like to hone that until it's really good. All right, and then like I was saying, even if there's nesting, it can handle that too. It will actually set up the parent table and the child table and the foreign key linking them. Inserted it. Now we've got a knights table, and we've got a followers table with a link between them. So yeah, that's a lot of fun. All right. Once your data is in the database, you're probably going to have some team writing up a web app, and goody for them, and you're not going to get deeply involved in that. But if you can provide a RESTful web service, that's a lot of the battle, because if you can expose data that way, then you can kind of forget about it and leave it totally up to them. They can treat the database as a black box. You can have one app team developing against the RESTful web service. You can even turn it loose to the public and say, hey, develop your own apps against our product. Here's the web service. It's a neat way to do things, and it can be surprisingly easy. There's a couple of packages in Python that can do this. One of them is called Sandman. After you've installed it, this is absolutely all you have to do to point it at a database, and I'm going to jump out and do that right now. I did add, I'm just setting up a virtual environment, so I want to show you that I'm not cheating. I run that, and this does two things. First of all, it provides this admin interface that you can use if you want to, if you want to change somebody's name. That's great. And that actually, except that I auto-generated these, and so let's try that. There we go. We just changed Lancelot's name. So that's one of the things you can do. But you can also use it as a browser of objects. Okay, and this is all fine and dandy. But if you go through an HTML interface, you get that. But if you say curl it, then you get the JSON back. And I didn't write this. I wish I did. Or you can even, I just curled the entire nights table and got the JSON for that. So, if somebody, if they say you need a RESTful web service, tell them, yeah, okay, I'll need a few weeks. And, do that and then go on vacation. Another project, how many of you know about HTSQL? Okay, it's advertised here sometimes, but it definitely deserves a plug. It's a really neat, again, you can think of that as another RESTful web service, but it supports a really madly rich query language. So I am going to, it's very similar in that all you do is point it at your database and start it up. Let's see, that's on 8080. And then this supports queries like, yeah, I just asked for the nights table and it gave it to me. And you can filter. Here I have just the brave nights. Here I have just the brave nights that weigh more than 1 kilogram. And you can ask for what format you want the data in. If you explicitly ask for JSON, that's what you get. So now you have a classic RESTful interface there. So another really neat project. Okay, so you've got it, you've messed around with it, you've served it, now it's time to visualize it. Matplotlib is not a new project. It's actually pretty old. It's basically Python's response to MATLAB, but with the pandas integration part is new, so that's my excuse for putting this in a what's new sort of presentation. If you remember, we built this data frame called Leslie's, and I'm going to make another pivot table. I'm going to call it Leslie Summary because I wanted to see how the name is doing through the years. And this is well and good, but we want to really visualize it. Well, this is how easy it is to get a plot of a pandas object. Ask for the plot. That was really, really hard. So yeah, name Leslie is not thriving these days. Here's an alternate pivot table where we're looking at the name distribution between genders. Hang on a second, did I miss something? Ah, there we go, okay. So I took that pivot table, and then I called plot on that, and I just said, this time I want a horizontal bar chart, and a stacked horizontal bar chart. And sorry, this is really hard to see, but there is a little green stub on the end of here for boys named Leslie, and for all the other names, it's an insignificant stub. But the point is, Matplotlib supports a whole bunch of different kinds of plot objects, and it ties in really nicely with pandas data frames. All right. Stepping back to the year of birth 2000 data. What do we have? Oh, histograms. Yeah, that was pretty easy. So this is basically showing you that everybody wants a unique name these days. This is how many kids were named with that name and how many names there are in that bin, and all the names are rare names these days. So we all have to be special snowflakes, or our children do anyway. Let's see. Here's that androgyny pivot table that I had worked up before, just a little reminder of that. How about we are going to do a scatter plot here. And wish I knew a good way to zoom on this. Sorry about that. But we're doing a scatter plot, and we're setting the size for each point to be proportional to the number of kids with that name. Because what I was curious about was I thought that maybe these longer names would skew toward the female and the shorter names would skew toward the male. And that's really only true for these names at the extreme. Everything else, I don't really see my pattern. But another nice chart. OK. Now, if you really want to see some of the neat stuff Matplotlib can do if you get a little bit into it, I can't duplicate all these awesome charts, at least not in the time I have. But we'll even skip down to some of the really impressive ones near the bottom. If you just want to know what the potential is in Matplotlib, it's, yeah, you can definitely, this will impress people who wear neckties for sure. So, yeah.
So is this the, like, visualize the data in your database by coding it through pandas and then use the extension to just...
That's the idea. Just yank it into a pandas data frame.
Yeah.
And these are, of course, really easy to publish to a web page or something like that. So you can generate a web report. You could even automate the process of generating one of these.
Well, with the notebook, you don't even need to do that.
Oh, sure.
That's it. Just do it right there. You're done.
Right, exactly. Yeah, exactly. So again, I would love to see some notebooks that, I would love to see some notebooks that say query performance data and then plot that with some explanation of why you care if this line is going up or down or something like that. All right, a basic Matplotlib chart is not interactive, but there's an MPL D3 library, and the D3 stands for D3. That basically re-implements Matplotlib on top of D3. Now, if you want to do, you've probably all seen some mind-blowing D3 things, and if you want to do that, you can do that in the notebook, but there's no particular shortcuts. You have to do it yourself. You have to learn crazy JavaScript and everything, and I haven't gotten in that deep. But there are some things that this gives you almost for free. If you enable this within a notebook, and then I'm going to do that same plot again, if you see these little faint icons here, now I can move that around. I can zoom. I can go back to home. So it's a little more useful. Yeah, and that's all. And that includes, if this is, even if this is posted as a quote static web page, there's JavaScript that will still make this all work because it's just D3 and D3 is JavaScript.
So how long before we get the D3 functionality nicely just wrapped up into pandas?
10 seconds. So, sort of. MPL D3. It doesn't make everything in D3 easy, but it makes it relatively easy to write plugins which encapsulate certain kinds of D3 functionality and use them in these plots. So that's basically what this is doing. Now I had to step away from I can't just call this as dataframe.plot anymore. I have to call a freestanding command to set up my plot. But at that point, I'm referring to the MPL D3 plugin, which creates live tooltips. And I'm passing to that the names that correspond to each of these points. And then I just connect that tooltip plugin object to my plot. OK, same plot as before, except now when I hover, Dominique, that's the really long sort of feminine name. And Ali, OK, and all the others are sort of in between. Peyton, Jordan. Where did Jesse go? Skylar. It would be on the 0.5 line. Amari, Jesse. There we go. OK. So, yeah, lots of possibilities there. And there are even, check back next week, because people are really excited about D3. There's been, they're writing plugins, yeah. There's also, even separately from MPL D3, I know that there are other efforts underway to get your notebooks D3 empowered. I'm not sure what their status is right now, and they were a little much for me to take on to try to squeeze into this talk. But keep an eye on it, because there's neat things happening. Because those JavaScript kids shouldn't be the only ones with the cool toys. Another plotting library is called Bokeh. It is a lot. It is based on ggplot, whereas matplotlib is not based on. It's kind of a response to ggplot the way matplotlib is a response to MATLAB. So for the most part, it's pretty similar, but it does have more interactivity built in without having to go out to this MPLD3. So here's an example. What I'm doing is I'm mapping colors onto my points, and that is just, let's see, I think I need to, there we go. I have to tell it to output to the notebook and tell it to show. All right, so here's another way to do a different kind of plot. This one has numbers. And the interesting thing here, this one comes with that sort of scrollability, for instance, built in. So bokeh is just another option when it comes time to give that a try. And if you want to see, some people have demonstrated some just insanely complex, beautiful things with bokeh. Now, it takes a lot of code, so I didn't want to get into that. That's maybe more than you want to. Oh, why isn't that displaying? Do I have to execute that? No. I am really puzzled. I don't know why that is not displaying. That's supposed to be a periodic table. Let me try this one. For heaven's sake. I don't know why this didn't show, because this is an NB viewer. All right. There's some beautiful stuff out there you can do with bokeh. You'll have to trust me on that one. All right. And there's more. Open NodeBox OpenGL I didn't even look at, but it's another highly interactive one. HTRAF is a JavaScript library that's based on HTSQL, which I showed from before. The plotting is not that advanced, but the neat thing about it is that the queries, basically you write a static web page, you embed HTSQL queries in the static web page, and then it renders pie charts and graphs and things like that. And you can actually wire those together to let the elements affect each other. Like you can have a drop-down. The elements in the drop-down were pulled from the database by an HTSQL query. And then what you select in the drop-down determines, determines what goes into the pie chart. So I don't have a live demo for that one, sorry, but there's really cool stuff there. OK, so I have rushed through a little bit of what the Python world is up to. I hope I've convinced you that it's worth staying in touch with your old friend, Python. So how are you going to do that? Well, you could certainly come to the next PyCon in Montreal. It's going to be a blast. I love Montreal. You could look up this whole PyData series of conferences. You could come to PyOhio, my baby conference. It's less than 5 hours from here. In fact, if you're a Chicago driver, it's less than 3 hours from here. It is free every July, and we have a good time. And then, of course, you jump on. There's a Planet Python corresponding to Planet Postgres. Just try to keep an eye on things. Look if you've got a local Python user group. Hang out there. Sometimes you'll learn lots of neat stuff. So thank you very much. I'm ready for questions. Yes?
This is really awesome for exploring data. Have you used pandas in any sort of real-time system?
Real-time system? I have not. You would need to. Can you elaborate on what sort of system you're thinking?
Sure. If you wanted any sort of dynamic decision-based thing where you wanted to build some model, risk, whatever.
Right.
Yeah, and have that adjust sort of on the fly.
I see. I don't know if you could make it push and refresh without. I don't know if you can have it do that. I haven't stumbled across that functionality, but it's never safe to say it can't be done. So I'm not sure. Good question.
Have you played with any of this inside of PL Python?
No.
So put your trigger on the table,
Yeah.
then go rerun it through PL Python.
Generate a chart, save it to a table,
Generate-
serve it up later.
I would
So
be a
that's-
tiny bit nervous running that level of Python complexity through PL Python.
Well, and the thing,
Panic the database, that's what could go wrong.
Well, for a monitoring database, I don't think about it. And not upsetting to that.
Yeah, I mean, there's certainly cases where you could do it.
yeah.
So that's the PNG bytes from, because you can select out a byte array.
Now, the tricky thing is, I mentioned earlier that you might want to use a third-party installer because there's a lot of dependencies, a lot of C-based dependencies in here. NumPy, the underlying technology has dependencies coming out the waz. And so getting that installed in PL Python might be really hard. But wow, it would be worth. Please do it. That would be awesome.
All you need to do is theoretically, you just get it installed.
That's right,
in
and
the OS Python.
right, and refer out.
Postgres is just
Yeah,
running
that's
through
right.
that.
That's right. So maybe that could be done. Oh wow. Okay, I want to see this.
When you pulled in the Wikipedia
Yes.
URL,
Yes.
that was your code in DDL generator?
Yes.
Is there anything similar like that without having to step through a database table first? You just call in
Sort of. Okay, so
like a non-persistent equivalent of finding out the most populated cities or something?
well, DDL generator, I split out from that project a Python package called data dispenser, and its job is to basically generate ordered dicts, which is a row-like data form. And you should be able to point that at something like a database and get them back. So if you don't want to, then DDL generator takes those and uses them to build SQL table definitions. But you could interrupt the process and just go directly to a data dispenser, and it should be able to look at that page and fire back at you tuples saying, Columbus. Into a data frame. Well, yeah, you'd wire that up yourself. That would be, yeah. Oh, I see what you mean. Yeah, hasn't been done, but it shouldn't take a lot of code because getting a data frame from something like a Python list, super easy. That's a one-liner. So yeah, you could do that. Yes.
It's kind of complicated.
It's partially because I went so fast. But.
No, yeah, well, when you show it, it looks really easy.
Uh-huh.
But like for a scientist, those are quite complicated things. No, not for a human being. Like there's one thing, and then the same goes for Wolfram Alpha's
Right.
thing,
Right.
which is kind of a competing thing.
Right.
Like it looks super easy when Mr. Wolfram himself, when he demos it.
Right.
But who can remember all those commands and by heart?
Right.
And nobody ever, on the same hour, generate a pie chart followed by I don't know, an aggregate to something. It's almost unrealistic that you would do multiple things in the same day.
Plausible.
How do you come over that problem of the fact that it's hard to remember all these things?
The notebook helps some in that I'm.
That's my point.
Right. Yeah. This one. Well, and unfortunately, the notebook helps some in the sense if I'm going to make a new scatter plot. Oops. If I don't remember what I can do there, okay, that's right. I scatter. I'm going to pause. What do I do now? And that pops up some information. So that's a significant memory aid. But I'm not going to say it makes it all easy. And I'm not really imagining that you're going to turn this over to anything like an end user. But if you have data analysis, those people, snobs with Macs, if you have them in your company, they should be able to handle this level. But and just provide crib code, stuff to work from that is approximate. Between that and the help, you should be able to work it out. But yeah, it's still programming, and that's why I didn't even touch on D3, because when you've seen beautiful D3 stuff, it's gorgeous, and then you look at like the 3 pages of dense JavaScript, and you go, oh, I've got a headache. So yeah. This is.
Honestly, this looks better than most of everything else I've seen. The advice I got from senior engineers who played with this. Any data visualization is you sink 3 days before you get to produce anything useful.
Yeah, this one we're down to, like in this case,
Well,
5 lines. They're dense lines,
Well, until
but
you feel comfortable doing just approaching a problem and being able to
Right.
apply it
Right.
directly. It's
right. Yeah.
If I could get rid of these two, then it's very straightforward.
Right.
With Matplotlib, it was just
Yeah, we did when we were sticking to. Now, of course, there's some work in basically learning what all Matplotlib can do, but where did that go? Oh, I'm not going to be able to find it. The navigation in this is a little bit funky, but yeah, when it was really simple, we could just take a data frame and say dot plot, open paren, close paren, to the end, and it generated a nice little line plot. And if that's all you need, then that really is dead simple. It's just when you start trying to really impress people that you have to add some complexity.
Well, I wonder too about being compatible with whatever platforms the end user has their information in. So like if someone hands you like an Excel file and it's like, here, visualize this for me. Like, whether or not you can spit that out in a quicker or
Yeah, well, Pandas has that read Excel function. So, I mean, I think you stand a fairly good chance there. Yes, don't let people use Excel. Okay. All right. Well, thank you very much.